AI scientists. Now, this session, of course, will shed some light on the transformative power of generative AI, uncovering some of the challenges, the breakthrough, and promising horizon that lies ahead. And to present this talk, we have with us Jaiprasad Hegde, who is the Head of Data Science and AI Initiatives at National Payments Corporation of India. Well, Jaiprasad leads innovative initiatives in ML and AI to transform India's digital payments. Well, with over 2 decades of experience specializing in AI and ML and data science, he's somebody who's focused on fraud modeling, computer vision, voice recognition, and much more. And I feel with the kind of experience he garners, we wouldn't have had anyone better than him to share his perspective on Gen AI and its transformative power, because we have somebody who has applied the same. So with that being said, I won't take much of his session time and call Jaiprasad on the stage.
I hope everybody is able to hear me. Good afternoon, everyone. I hope you had your coffee. It's usually hard after lunch, so I understand. But so this is a very different perspective, and I want to bring a slightly different vantage point to the overall proceedings. I know everybody's gung-ho, looking at a dreamy future of Gen AI. There are managed infrastructures available for you. There are ethical considerations and so on. But I want to give it a much more personal touch here, right? So this is generative AI from a data scientist lens. So this is singular, but maybe there are aspects that we all find common here as we proceed. So my name is Jaiprasad Hegde. I head the data science team at NPCI. To give you a quick ready reckoner about NPCI. NPCI is the digital payments infrastructure, operates the digital payment infrastructure for things that you already know about, and we attempt to touch the life of every Indian. So we architect and build stuff like UPI, IMPS, CTS, NACH, NFS, which is your ATM switches, other payment systems, RuPay, every bill that you pay through Google Pay, Phone Pay, Paytm, for instance, digital rupee, and so on. Now, of course, these are massive India-scale projects. And to do it justice, we have a homegrown AI platform built on open source from the ground up. So we have large engineering systems, large data engineering systems. We have a need for high speed and high volume inferencing. We have large training workloads. We have large analytics. I think you can understand where this is going. I'm using the word large quite a lot. We have a notebook ecosystem for in-house data scientists. So think of a collab for data scientists that you spin up whenever you want to, for instance, right? And we do prototyping, in fact, fast prototyping at larger scales. The scales that we operate on, even for a prototype, are very, very low. All of this is not on somebody else's managed infra, not on a public cloud. This is all in-house. So we build from the hardware upwards. Hardware, the stack, the software, everything is ours. And the teams that operate this is all ours. So something about me. So I come from a unique multi-generation AI background. So I started my career doing stuff like genetic algorithms that I'm not sure is even in the vocabulary of most AI guys right now. Doing things like building transfer grammars, machine translation, doing information extraction from newspaper articles and stuff like that. And then moving on to full machine learning approaches, information theoretic approaches, Claude Shannon's work, for instance, an application to machine translation, information retrieval. And then moving on to multiple initiatives within the world of AI. Traditional machine learning, of course, deep learning, graph AI, and many others. I'll keep it brief. Now, today's session, like I said, I wanted to present a very unique vantage point and something that sort of bubbled up while I was doing the general literature survey in the world of generative AI. It's also an outside-in perspective, not just as an AI practitioner. So let's say if you are a pure data scientist who has rich experience in the world of data science, AI, machine learning, statistics, what have you. What does it mean? What does it mean purely from a skill set perspective? What does it mean from where the world is headed? Right? So there are questions that I want to raise. I want you to sort of stay along with those questions too. Should be something as a food for thought as you go home. So today's session, these are the three primary points, but techniques are still important, understanding the role, what works for you. But I'll start building it up from a very different perspective. You'll understand why I keep saying very different perspective. So I started taking a look at this overall discussion about AGI. And one question kept coming back to me. Why do designers keep talking about AGI? So AGI, you know, right? It's a superhuman intelligence. It's a very dreamy concept. It's an ambitious concept. In fact, the word artificial intelligence was supposed to mean what AGI stands for right now, and they coined it. But it became a collection of techniques over a period of time. So even things like search, spell check, recommendation systems, those formed a collection of techniques under AI. So you end up defining AI as these collection of techniques as opposed to the AGI definition that it was supposed to mean earlier. And coming back to the conversation. So AGI stands for a superhuman intelligence, a dreamy concept. And there is a definite reason why the designers think it is reachable. And for the first time, they think it's going to be reachable soon, right? I don't want to dwell on the part where the LLM is growing, the capability is growing. But if you take a slightly ingenious outlook about why this definition is more practical than ever, you'll understand closely why they keep saying that. Because the first factor which we cannot ignore is the capabilities of the large language model march on, right? We keep on thinking LLM as an autoregressive machine, it is going to do the next word prediction, feed in the context, back again, you'll get the next word, which is even better than before. Maybe this machine is Einstein himself, and you'll get a better answer every now and then, right? But thinking of LLM as a chatbot or an expert generator, I think is a current perception. And this will change very, very soon. The reason why I say this is because LLM is trending towards an engineering concept called as the LLM OS. And this is a straightforward screenshot from Andrei Karpathy's talk. So you have the laws of scale, right? Larger data fed into larger architectures, which means they're going to learn more, right? They understand context better, they can answer better. And if you hear the words of the fast AI founder, Jeremy Howard, we should not try to go down, we should not try to be the 1.5, we should try to grow as many parameters as possible. Right now you get system on answers, which is assistive immediate answers from the LLM. Right? There is the usage of RLHF for training, reinforcement learning through human feedback, and I was personally very excited to see the word reinforcement learning entering the vocabulary after so long a time. So which means the LLM is answering something, And there are people who are looking at the answers and rating those answers, whether they're good or bad, or editing those answers to be fed back into the machine, right? So that's how your chat GPTs came into the picture. And now, people are taking that concept a step further, wherein you could have an LLM rate the answers of an LLM and a human supervisor on top of it, right? So that's RLHF on steroids for you. So it already makes it sound very dreadful and scary, but it's how technology is moving at this point of time. A lot of scientists looked at this system on thinking and thought that this immediate answering system, this assistive answering system is not enough. We need something like an AlphaGo machine. Now, to give you context about AlphaGo and how it differs from something like Deep Blue, which defeated Gary Kasparov like years ago. Deep Blue was built on like a massive search system, so it could search for all the games of all the players at any point of time, do a min-max and adversarial search depending on your position and figure out what the next position should be to defeat Gary Kasparov. A pure search operation at large scale. On the other hand, AlphaGo was not fed all the games. It was fed some players' games. And then it went through a self-improvement phase, where it kept improving and improving and improving until it met the guy to beat, right? So what if those capabilities are built into LLM, which is like a system to thinking, if you think of the Daniel Kahneman book, Thinking Fast, Thinking Slow, right? System to thinking is thinking deliberately, thinking about something that you've not taken a look at earlier, thinking about it deeply, formulating the answers, generating those answers, right? You can clearly see that that part is missing right now. Right now, the LLM behaves like, I'll use the word, one of my heroes, Isaac Newton, who's met every professor in the world of physics. He's read all the literature from physics. He's able to articulate his answers very well. He's able to summarize his answers very well. He's able to collect information from whatever he's read and generate those answers very well. But he's not learned how to discover calculus yet, right? That's what we're trying to do here. How can we self-improve to create something brand new? Your LLM could refer to search, so they already have access to things like Bing and Google, for instance. And they can refer to like special runtimes or Python code environments to run their code. So you could ask an LLM a question, it can go back to this runtime, execute that code and come back to you, which is very dangerous territory once again. It has the access to the file system for related purposes. You want to maybe search on set of documents that you have as opposed to the documents that OpenAI has, or Google systems, Gemini has, for instance. And if you look at the recent developments, this particular system can even refer to specialized LLMs that you have developed. Maybe you have developed something for legal purposes, for financial advice purposes, for tax purposes, for your particular domain. Maybe you created a Python code generator, a Lua code generator, what have you, right? You would possibly upload these specialized LLMs into the App Store to build a largest ecosystem. So now, inadvertently, you are part of that same ecosystem. You are building the same machine that is getting stronger and faster, right? And of course, it is equipped to talk to humans, meaning it is equipped to look at information that we interact with. So which means instead of only text, it can interact with video, it can interact with audio, it can interact with text. And so, like I said earlier, can the important question still remains. Can they solve problems that they have never seen? Can we truly experience emergent intelligence? And that word comes from robotics, wherein you have a swarm of players having very simple tasks, but the effect they generate is something equivalent to like a row of ants carrying a stick towards a common destination. Each ant might be doing a very simple job, but effectively everybody is carrying that stick, right? So that's emergent behavior approach. And this is the part which is important. I mean, we are headed towards, if I'm taking an engineering outlook, we are headed towards building of this kind of an operating system, which has access to all these faculties simultaneously. It's not one or the other, it's the entire shebang in one single go. It could access its own LLM, it could access a specialized LLM, it could do system 2 output, it could do system 1 output, it could do search retrieval based on Bing access or Google access, for instance. It could do actual search retrieval to a search algorithm, for instance. It would try to auto-improve itself, and you have RLHF systems all enabling this also. Meanwhile, you're feeding in audio, video, enabling these multimodal models to function even more effectively than before. So this is a monster machine which is getting it, wherein the RAM stands for the context window, and the LLM is the central foundational model that we use. Where does this leave us? Or where does it leave me, for instance? If I'm thinking as a data scientist, what does it mean for me? So the thought that I was left with is, it seems that the LLMs will be able to solve almost everything in the near future. Right? And we are playing along. We're building this massive machine. However, I think it's important to note that although it looks like a interesting, promising horizon or a scary prospect, depending on who you ask, the key to remember always is that you don't need an LLM for everything. Right? So just to give you a contrast, right? So Andrew Ng, everybody knows Andrew Ng, the founder of Coursera, the famous Stanford course. So for instance, he's been at the forefront and he's seen generative AI applications get built every now and then. Right? And he's seen how the industries proceed. One of the advices that he gives is, start with the business problem. Don't treat LLM as a first step in starting a business. Figure out what is the business problem, how you're going to solve it, and then see whether there is a role for LLM to play along. I'm going to elaborate that further as we go along, but I think this concept stayed with me for a while because I see almost a mad rush for doing LLMs without an understanding of how it's going to impact the business. The second part that lingered with me is that the building blocks will continue to matter, right? Along with standard deep learning concepts. So if you're working in the world of generative AI, you would have come across these words: stable diffusion, variational autoencoders, generative adversarial networks, transformers, and so on. If you not come across this word, then it's a matter of concern, right? Then we're losing the fight. Right? We're not working on the craft, but we are working on the end application. Yeah, transformers is the current go-to chat, right? That this person is going to do everything with transformers. And of course, the extended family that comes along with these, the BERT, the RAG, the newer embeddings which are coming into place, the new multimodals which are coming into place, the mixture of experts techniques. Some of these techniques even go older, go much earlier. And reasoning, things like reasoning which are coming to the picture, right? Even aspects like agents are coming into the picture, which is an interesting word. So if you start reading the textbooks like 20 years back, and you had this set of concepts. You had machine learning on one hand, you had intelligent agents, you had case-based reasoning, you had genetic algorithms, evolutionary algorithms, you had reasoning, you had search techniques, you had information retrieval, NLP techniques, and so on. So you are seeing almost a culmination of all these techniques coming to play back again in a very interesting manner. And it's important to grasp onto those techniques as they're coming here, right? Rather than just be at the edges of usage. I'll dwell on the story of BERT and to give you a picture of why this discussion is important and what role maybe I have to play or you have to play. So you all know BERT, right? So BERT was one of the earliest transformers that allowed Google to improve search results, right? So Google was simply doing a lot of text matching based algorithms or pure information retrieval algorithms back then, right? And they needed a much better way to figure out how do we do query translation from the query that the user is providing to something that makes sense or is in and around that area. So they started work on using the transformers for such an application, which is better query translation so that they can get a series of results which are nearby related, but don't necessarily have the same set of words that the user has written. So which means that they had to sort of create a large language model trained on Wikipedia for 2.5 billion words and books for 800 million words. And if you look at the engineering side of the story, they had 64 TPUs working non-stop for 4 days to just create this model. That's the engineering side, the data engineering side, the data science side of it, which is, and we get to see only the user side right after BERT has been released. But the first attempt to do something like this is quite amazing, even at their level. Of course, for smaller bird families have emerged which are doing an effective or equal job. But which hat should we wear here? Meaning, which hat should I wear, for instance? So, for instance, are you going? Do you intend to aspire, or do you aspire to be the creator of BERT or equivalent, which possibly deals with newer languages, which is an amazing field, right, by itself? Or do you want to apply BERT to brand new application here? Something like name entity recognition or intent recognition, for instance, which is used for right now. So these are very interesting applications by themselves, right? But the kind of data scientists who use these are not the same data scientists who are creating BERT. So very different outlook for these two sets of folks. But and then persisting with some of the earlier topics that I introduced, right? These techniques still matter. Diffusion still matters, right? I mean, although we use it with anything. So diffusion is great for image generation. You have the genesis of DALL-E, stability, Midjourney happening because of this technique. And amazing technique. I mean, you basically deconstruct that image, go towards noise, and from noise you come back to reconstruct the image, and along the way you figure out there is a generative prospect here from noise to back to the original image. Then you have a technique like GAN, for instance, right? It's just things like style transfer on existing media, same actor, different languages, etc. Right? Of course, I'm giving positive examples for GAN. Then you have the heavyweight champ, right? The transformer. You have the encoder stack where you utilize the BERT, and you have GPT and its siblings. I'll spend a little bit of time on GANs and you'll understand some of the perspectives. So GANs is popularly used for style transfer, right? Meaning you would have seen the negative examples also like deepfakes, etc. But so think same movie, different languages. Right? If you want to dub the same actor, different lip movements. So I'm in Bangalore, so I can say this. I think we remember Puneet Rajkumar very fondly, right? And he passed away at an early age. And there was an unreleased movie, Puneet Rajkumar, The problem the movie makers were stuck with is we have this movie, but we don't have a voice. We don't have a voice dubbing for the movie. So they approached dubbing using his brother's voice. I think people know this story. Now, apparently, the producers also approached a few colleagues of mine in IIT Hyderabad to do a Puneet Rajkumar voice on Puneet Rajkumar's frames, right, movie frames. And you can understand what technique is getting applied there. So your input is that brother's voice. The style that you're taking is Puneet Rajkumar. And the output is Puneet Rajkumar voice ditto for taking into account all the cadences, all the nuances, all the pauses that his brother has imposed with the voice of Puneet Rajkumar. And apparently they re-released the movie again. So this is the example, this is the positive example that I'm talking about cats. It's quite dangerous in this election year. But same actor, different lip movements, right? And you also talk about super resolution, which I'll come to in a minute. So the questions are this. You consider this as a style transfer application. What is the first thought process for you? See, it's not necessary that you go to a GAN only. Do you use an LLM for this? Do you want to start by generating image first with a description and then take it to a GAN, for instance? Would you like other techniques to do this for you? So I come from a world where we operate our hardware ourselves, right? So we don't have managed infrastructure, but we manage infrastructure ourselves. So space, time, and space compute is a definite constraint. And people take that for granted when we basically go into managed infra. But for us, this is a definite point of consideration. Also, things like where do you intend to use this? I mean, if you start with LLM, is that always your go-to point as an API endpoint? Is edge ever going to be in the picture? For instance, when you use a technique like super resolution, so you have an HD image, you want to convert it to a 4K image, all you need is like a DLSS technique sitting on a small card attached to your TV, which will generate from an HD to a 4K. And that is a GAN in the picture. It's a super resolution technique which can do that. But that sits on that tiny little chip. Right? It's not sitting on a fat chip on some server, right? It's not like your H100s or what have you. So does this thought ever cross your mind, right? Do you think that sending this to an LLM or a VLM is an overkill? I mean, I think about it all the time. Meaning, what are we getting out of it is, for lack of a better phrasing, is the return on investment commensurate to what you're doing? And finally, I want to leave these thoughts with you. As a data scientist, where do you want to spend most of your time? I'm not giving answers. I looked at a lot of the presentations earlier. A lot of the presentations were filled with certainty. This is how we should go. This is the open source technique that we should apply. This is the managed cloud that we should go towards. This is how we should apply VLM. I love all these prescriptive advices, but I have a lot of questions myself. How do we do all of these things? Or where do we spend our time? Do we continue finessing all the language models? Do we continue doing fine-tuning? Do we go with curated data sets? Go with much more task-assisted data sets? Do the entire thing all over again? I think one of the previous presentations had that. Is that worth your time? Should we ever consider smaller models on a smaller GPU at all, right? I think 1.5 from Microsoft is a great initiative. I think we're looking at smaller models, but would those models ever fit on like an edge device? And if you're looking at large models, right, how do you distribute the workload? You are doing essentially supercomputer level engineering at that point of time. If you're doing trying to build an LLM yourself, which is large models, large training workloads, long hours of training, distributed training. You might end up using like distributed PyTorch, forward, what have you. But that effort does not come cheap. And again, I'm taking a very unique perspective because this perspective is, I don't think a lot of the audience would have that perspective, because you would end up utilizing managed infrastructure. But this is a perspective that I think about. Meaning, if I have, let's say, 5 H100s, am I going to devote the 5 H100s to training in an LLM all the time, or am I going to use it for like a definite application which has a use case immediately? Am I, in a sense, doing supercomputer programming here? Right? Is edge computing ever on the cards? Meaning, is federated learning, federated inferencing ever on the cards for folks? And these are engineering topics. I think people don't really discuss that. But it's something that is a question for me when we take a look or we take a step towards LLM all the time. Right? As a community of data scientists and data engineers, what are the workloads that we are choosing to ignore in terms of convenience? And convenience comes very easy, right? If something is convenient, you tend to take that step as opposed to anything else. Right? So, what are you losing when you are taking the step towards convenience? Are there craft-related aspects, right? Data science as a craft or data engineering as a craft that you're losing along the way? I mean, are there skills that you're losing along the way? And that's where I want to leave the audience with. Meaning, these are questions to be answered, I'm not sure, by a better crowd, possibly, better, much more informed audience, I suppose. Thanks, I'll leave this. This is intentional to leave it on a hanging note. If you've got questions, feel free to ask.